Giving a test to a group of students, the grades and gender are summarized below. If one student is chosen at random, find the probability that the student received a B in the class. All right, so the total number of students that received a B is 6, and the total number of students in the class is 47. So the probability that a student received a B is 6 over 47. So that's 0.128. Find the probability that a student is a male. So there's 19 students that are male out of 47 students total. So 19 divided by 47, that is 0.404. Find the probability that the student was a male and received a B in the class. So male and received a B. So if they are male and received a B, what you want to do is look at the intersection of those two groups and put that over the total. So 2 over 47. And you might be thinking that "and" is generally indicating to us to multiply probabilities. And we didn't do any multiplication here. And you'd be absolutely right. But the thing is, with these contingency tables, things are a bit simplified for us when it comes to events joined together with the word "and." So you can absolutely use that multiplication rule, but you have to use the one with a conditional probability. Or you can just do as I showed you and look at the intersection of events and move on. I think most people prefer the latter. Find the probability that the student received a C given that they are female. All right, so we know that the student is female, so restrict yourself to that group. So what's the probability that a student received a C? 5 over 28. Which is 0.179. Find the probability that the student is a female given that they received a C. So this looks like the same, but we've swapped the order of the events, and that makes a difference. So the probability the student is female given they received a C. So if we know the student received a C, that means they're in this group. So that's what's given now. Of that group, the probability of a female is 5 over 11. So 5 over 11 is 0.455. Find the probability that the student is a female and received a C in the class. So here we have the same two events again, but now we're joining with "and." So what I want you to see here is when we do the "and" probability, female and C, we still get a 5 in the numerator, but now our denominator is 47. So 5 over 47. That is 0.106. And the thing that I want you to take away from these 3 examples is that in all examples, the numerator was 5. But the denominator was the only thing that changed. In the given probabilities, you used these reduced items that I've put in green. In the "and," you use the total for the entire table. So the thing that you can be certain of is, unless you're doing a given probability, you're going to use whatever the total is for the entire table. Everything else, you just use the largest denominator. You use the total for the entire table. But if you're doing a given probability, you use one of the denominators from the column. And if you circle or highlight or do something to restrict yourself to the part that's given, then it makes these problems kind of impossible to miss, because generally speaking, when I give a given probability in class, students either put 5 over 28, 5 over 47, or 5 over 11. But if you restrict yourself to the part of the table that's given, your only possibility for an answer then is basically 5 over 11, which is the correct one. Find the probability that the student received an A given that they are male. All right, so we know that the student is male. We're going to restrict ourselves to that portion of the table. The probability that they received an A. There's 11 males that received an A out of 19 males total. So 11 over 19 is our probability. .579. Find the probability that the student received an A and they are male. Okay, I apologize for having to scroll back and forth here. So we're looking for the probability that they received an A and they are male. So we're looking at the intersection of those two groups. And because it's not a given probability, we just use the total for the entire table. So 11 over 47. And that is 0.234.